Okay, so on to question number 2. Determine whether each molecule given below is polar or nonpolar. Let's write down the definition of polarity. So polarity arises due to the separation of electric charge. So this leads to dipole moments. And usually this happens when like one side of the molecule is slightly positive and the other side is slightly negative. Okay, so let's look at the options they give us. So for A, CF4. Let's draw that out. We have our carbon in the middle, and 4 fluorines attached like this. So let's just write some like notes about this. So fluorine is more electronegative than carbon. So if I were to only look at the bonds on their own, you'll see that since fluorine is more electronegative, the dipole moment goes towards the F. So its bond is polar, but if we look at the molecule as a whole, all these fluorines cancel each other out. So the bond is polar. But CF4 molecule is nonpolar. Okay, so let's look at the next molecule they give us, PBr5. So this looks like following, where you just have the phosphorus in the middle, and then again all the bromines kind of stick out like this. And again, they all cancel each other out like that. So this is a nonpolar molecule as well. Okay, let's look at the third one. Xenon F2. So here, there's going to be some lone pairs involved. But if I draw out the fluorines, they still cancel each other out like this. So this molecule is also nonpolar. And then lastly, D, SF6. You get the same effect over here, where they all just cancel each other out. So this is also a nonpolar molecule. So these are all examples of nonpolar molecules, but I guess I'll just show what a polar molecule would look like. So we can do everyone's favorite, which is water. So you have a more electronegative oxygen and lower electronegative hydrogens. So this side has a slightly positive charge, and the side with the oxygen, which is more electronegative, is more partially negative. So this would be an example of a polar molecule. Okay, so let's see what our junior tutor said. So it looks like they were given different molecules all together, but the answer is correct, what they said. You can see, so this molecule is an example of a polar molecule. If you were to have 2 chlorines on one side and then 2 hydrogens on the other, then you have a dipole moment going towards the chlorines. So this is a polar molecule. And then here we have another polar molecule. So I'm just gonna verify with the molecules that were given in the question. In this question. So all molecules are nonpolar in this question. The theory in the solution is correct only. Okay, so solution is incorrect.